Day 276 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 190, reverse bits. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as possible. Now let's see before we see what the question says though, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description. Now let's see what the question says. Question says, reverse bits of a given 32 bits, or excuse me, reverse bits of a given 32 bits unsigned integer. Note that in some languages such as Java, there is no unsigned integer type. In this case, both input and output will be given as a signed integer type. They should not affect your implementation as the integer internal binary representation is the same whether it is signed or unsigned. In Java, the compiler represents the signed integers using 2's complement notation. Therefore, in example 2 above, the input represents the signed integer -3 and the output represents the signed integers negative, I don't know what is that, negative 1,073,741,825. So let's go ahead and look at example 1 so we can know exactly what it is that they're talking about. But from the question, from the title of the question, we already know what they want us to do. They want us to reverse the bits, right? So in example 1, we have the input in, they give us this bit, or right here, boom. Then the output is 964,176,192. And this right here, this output is just the same as this bit but reversed. So explanation says the input binary string is this right here, represents the unsigned integer. Some big numbers, y'all. My bad. Let me see. 43,261,596. So we return 964,176,192, which is the binary representation of this, right? So as you can see, we're returning the binary representation or the integer, right, of the bit. So this is the reverse bit of this. So we take this, we reverse it, and then our output will be the real number, whichever this binary representation, right? Whichever is the binary representation or equivalent of the bits that they give us, that's the output. So that's why the output is not in binary, it's just a regular number. So let's go ahead and look at example 2. It's the same thing. So in example 2, n equals this binary string, or it's not a string, but this binary code right here. And this is the output, because this output, if we reverse this, it's going to become this right here. Boom. And this, the integer representation of this is this number right here, which is, let's see what it is. So 3,221,225,471. So we're not returning the bits or the binary code. We're not just taking the binary code and reversing it. We're taking the binary code, we're reversing it, and then we're giving we are returning the corresponding integer of that binary code, whatever it may be. They gave us some big numbers here, but we're not going to let that stop us because the compiler is going to handle all that for us. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult at all. So let's get into it. First thing we are going to do is we are going to declare a variable called num, and we are going to set that equal to n, right? So we're going to copy the input number n to a variable num so we can modify it. Then we need to initialize another variable. We'll call it res, and this will store the final result. The final result with the reverse bits. So we're going to come right here. We're going to say var res. We're just going to set that equal to 0 to start. And once again, that's going to hold our result of the reversed binary bits. Boom. Now we need to loop through exactly 32 times because we're dealing with 32-bit integers. So in order to do that, we're going to come right here. We're going to say for underscore n 1 dot 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 32, open up the brackets. Boom. So we're going to use the bitwise AND operator with 1 to get the least significant bit or the rightmost bit of num. So in order to do that, we're going to say let bit equals num and 1. Boom. Now we need to right shift num by 1 to move to the next bit for the next iteration. So in order to do that, we're just going to say num is greater than equal, should be equal 1. Boom. Then we need to left shift res by 1 to make space for adding the new bit on the right. So in order to do that, we're going to say res less than equal to 1. Boom. Now, if the extracted bit is 0, we can skip adding it to res and move on to the next iteration. So in order to do that, we're just going to come right here. We're going to say guard bit does not equal 0, else open up the brackets, we could just continue. And that continue is what's going to allow us to skip over. Then if the extracted bit is 1, we need to add it to res. This effectively sets the rightmost bit to 1. So in order to do that, we're just going to come down here. And we are just going to say res plus equals bit. Boom. Not done yet, because after processing all of the 32 bits, we still need to return res, which is now bits of n in reversed order. So we could just come right here and return it, and we'll say return res. And just like that, y'all, that should be all she wrote. Let's go ahead and run it, make sure it runs properly. Let's see, it's accepted, y'all. Look at that. So let's go ahead and submit it, make sure it stays accepted after we submit it. Let's see. Let's get rid of this. Ooh, look at that. Those numbers aren't too bad. 3 milliseconds beats 93.33% of users with Swift, y'all. Not too bad at all. I'll take it, y'all. So I hope y'all learned something today. I hope y'all are staying consistent, and I hope y'all are staying disciplined, because that's what it's going to take to be the best programmers in the world, y'all. We're trying to be the best Swift programmers in the world. So we're going to do these LeetCode problems every day until we understand what we need to understand to get that good job that we're trying to get. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.